Today, our question is, what is the maximum distance one can reach a toilet bowl through the use of peeing? So in order to determine this philosophically challenging question that has been debated for a millennia, we will first begin with a study conducted by the US government. Based on this research, the government has determined that approximately 235 to 325 centimeters per second of peeing was done from 37 individuals. Assuming then that the exit velocity is going to be 3 meters per second, and assuming a perfect scenario without air resistance, we can then determine the maximum range of peeing distance that can be obtained through projectile motion. Understanding that the maximum range for projectile motion is 45 degrees, we can then easily calculate this value with projectile motion equations to then determine the actual distance that will be obtained from these specific degrees. First, we will determine the x and y components of the exit velocity, and knowing that a 45, 45, 90 degree triangle is going to be 3 over the square root of 2, we then know both the x and y components of velocity. Next, we will determine the time each particle of urine takes to reach the urinal by focusing on the y component. We start with the kinematics equation of change in distance equals Vy times time plus 1/2 at squared. In this case, the change in distance equals 0 and the acceleration is negative g. We can then pull out a t from this. So now we get two answers where t equals 0, but we don't care about that because, of course, the height of the urine is 0 when you haven't started peeing yet. And the next answer is obtained from setting the second expression equal to 0, which yields Vy equals g over 2 times time. We can then determine that the time is 2Vy over g, which by plugging in the values we know the final time is 3 square root 2 over 10 seconds. Next, we will deal with the x component. So we have a change in x to be equal to Vx times t plus 1/2 at squared, but the acceleration in the x component is 0 since we can cancel that out. Next, we can plug in the Vx and the velocity to be 3 over the square root of 2 times 3 square root of 2 over 10. So we finally get the distance to the urinal to be 9 over 10 meters. The next logical step is to assume that we are standing on Mount Everest, which is 8,848 meters above sea level. We need to determine the maximum range a urinal can be on ground level so that its reach is 3 meters per second stream at 45 degrees. We have the same x and y components of velocity, and we will use the same kinematic equation from before. But this time, the change in y isn't 0, but negative 8,848, since that is going to be the final change in velocity of each urine particle. We plug this into our kinematic equation and we get a quadratic. We can now use the quadratic equation to determine the two final times where the urine is at that height. But we can discard the negative part of this since we aren't interested in negative time. So the quadratic formula is negative b plus or minus the square root of 2 of b squared minus 4ac all over 2a. Next, we can plug in the values for v, which is 3 over the square root of 2, and g, which is 10. Now we finally have an expression for time. Next, we can focus on the x component, and we have change in x equals vx times t plus 1/2 at squared, but a, again, is 0, so we can get rid of that. Now we plug in the values of v, which is 3 over the square root of 2, and we can solve for the total distance in the x direction the urine has traveled, which, when you put it into a calculator, comes out to about 90.6 meters.